Okay, today what are we doing here? We are solving radical and rational equations. Okay, so you'll notice all of these problems have radicals in them, or they have some type of a fractional exponent, okay, which is the rational equation part. It has a fractional exponent. So how do we get rid of a radical? Well, we do that by squaring both sides. Bless you. That was a loud sneeze. On the video, too. Everybody will hear it. Okay, so we're getting rid of a radical. You want to square both sides. Okay, so that gets rid of this. The radical and the square are gone. And we have 3x plus 18 equals x squared. Okay, which is where it gets kind of annoying, because notice we have three terms. We have an x squared term, we have an x term, and we have a number term. Which means in order to solve this, we're going to have to make a quadratic. So in order to make a quadratic, we're going to have to move both of our x in your numerical term to the other side and set it equal to 0. So we'll subtract 3x, so x squared minus 3x, and we're going to subtract the 18 also. So here we have this quadratic. Okay, and a quadratic is something that's very prevalent in algebra. We're going to solve this by factoring. So we're going to see what numbers multiply to give you negative 18, and at the same time add to give negative 3. Okay? So those numbers are negative 6 and positive 3. Those are the two numbers that multiply to give you negative 18 and add at the same time to give you negative 3. So once we have our factors, we can rewrite our quadratic in factored form. So you have an x plus 3 as one factor, and you have an x minus 6 as the other. Okay, and hopefully you remember from when you studied quadratics, if you have a plus as your factor, then we have a negative as your answer. So x plus 3 gives you a negative 3 solution, and x minus 6 gives you a positive 6 solution. Okay, so now here is the thing. It says check for extraneous solutions. Okay, an extraneous solution is an answer that we got down here that doesn't satisfy your original equation. Okay, so it's a solution that you got that doesn't actually make your original equation true. So let's see what happens. What if we plug in 6? Okay, the square root of 3 times 6 plus 18, does that in fact equal 6? Okay, so that's what we're trying to check. So of course 18 plus 18, that's 36. Is the square root of 36 positive 6? And the answer is yes. So positive 6 is a great solution because when you plug it in, you do in fact get what you started with. So let's now check negative 3. And something tells me that this might not work. So we have 3 times negative 3 plus 18. Is that equal to negative 3? Right, that's the question. So 3 times negative 3 is negative 9 plus 18. That's the square root of 9. Is the square root of 9 equal to negative 3? And unless we're solving, it in fact does not equal. So the square root of 9 is positive 3, which is not the same thing as negative 3. Okay, so that's what makes negative 3 extraneous, right? It is not actually a solution, even though it came up to be an answer when you solved it, when you did the algebra. Okay, when you plug it back in, it does not satisfy your original equation, which is what makes negative 3 extraneous and positive 6 your only solution. So let's check out some of these other ones. Okay, number 2. Okay, this is set up in our standard problem. We're going to square both sides. So we square x plus 3, and then we have to put parentheses around x minus 3. Okay, because you can only square one thing, right? So we don't square x and negative 3 separately. we put parentheses around it and square x minus 3. So on this side, the x and the radicals cancel out. But on the right side, we're going to have to distribute, because it means to square means multiply it by itself. So x minus 3 squared is x squared. And then we have a minus 3x and another minus 3x, so minus 6x. And then negative 3 times negative 3 is plus 9. Sorry, plus 9. So when we're squaring a parenthesis, you have to multiply it by itself. It's much more work than what it initially appears. So now we have all of our terms. We're going to combine our like terms. So we're going to move the x to that side, and we're going to subtract the 3 also. So 0 equals x squared minus 7x, and this looks like a plus 6. X squared minus 7x plus 6. So once again, this is our quadratic. So we have to think to ourselves, think. What numbers multiply to give us positive 6, and at the same time add to give negative 7? And these two numbers are negative 6 and negative 1. Okay, when you multiply two negatives together, you get positive 6 on top, and when you add them, you get negative 7 on bottom. So now we change our quadratic into a factored form, x minus 6 and x minus 1. So our solutions are positive 6 or positive 1. Okay, your solutions and your factors are always opposites. So x minus 6 gives a plus 6 solution. X minus 1 gives a plus 1 solution. Okay, so let's check and see if our answers are good or not. So if we plug in a 6 into here, 6 plus 3, well, that's 9. Is that the same thing as 6 minus 3? The square root of 9 is 3. 6 minus 3 is 3. So positive 6 looks like it's going to be a fantastic solution. That one works. But how about positive 1? The square root of 4, right? 1 plus 3 is 4. Is that the same thing as negative 2? Okay, we're going to say no, the square root is not negative. So we're going to throw away 1 as a potential answer. So we only have one answer once again, and the number is 6. So if we were to look for a pattern, it looks like your answer would be 6, right? So here we have a 6 for number 1. Here we have a 6 for number 2. I don't think it's going to work for number 3. But let's not do it anyway. Let's move on. Okay. Just for fun. Let's do number 6. Okay, first on number 6, you want to get the square root by itself. So we're going to add 3 to the right in order to get the square root by itself. Because you don't want to take the square a whole lot of stuff. Okay, so we're going to square x root x, and we're going to square x minus 6. Okay, so the reason I didn't do this is because doing that doesn't get rid of your radical completely. Okay, so even though it seems like a good idea at the time, that does not get rid of your radical, so that's why we add the 3 first. So let's see what we have. These ones cancel and we get x. Remember, this is x minus 6 times x minus 6, which is, there's an x squared. And then here's a minus 6 and another minus 6, so that's a minus 12 x's. And then negative 6 times negative 6 is plus 36. Okay, so yes, there's a lot of algebra in here. We have to be able to square a binomial. Now we're subtracting x from both sides in order to make our quadratic. So 0 equals x squared minus 13x plus 36. Okay, so let's get to factoring. So we're thinking what numbers multiply to give us positive 36, and at the same time add to give negative 13. What numbers multiply to give us positive 36 and add to give negative 13? Are negative 3 and negative 4. Right? Negative 3 times negative 4 is positive 36. So we take our quadratic and we write it in factored form, x minus 9 and x minus 4. And we solve them, and our solutions are opposite. So we have a positive 9 and we have a positive 4. So now we're going to go back and check and see, are these both good answers? Okay. Is the square root of 9, oh, that was really, is the square root of 9 minus 3 the same thing as 9 minus 9? Okay, and this of course gives you 0. 3 minus 3 equals 0, so check. 9 is a good answer. And now we go to our 4. Is the square root of 4 minus 3 the same thing as 4 minus 9? Okay, and this is going to be negative 1, and this is going to be negative 5, which is not equal. So positive 4 is once again an extraneous solution. Okay, so the problem with these radicals is that every time you get a solution, you have to check to see if it's actually good or not, which requires a lot more work than what you're probably willing to do. But to get it most correct, that's what you have to do. So let's look at these ones on the bottom. Check for extraneous solutions again. So here we have our power, x to the 3/2 power. Okay, so with our rationals, with our rational fractions, you have the power on top and you have the roots on the bottom. Okay, so if we're looking at a 3/2, we're going to cube this but raise it to the square root power. So if we're going to write this out, if we wanted to write it something maybe more familiar to you, this would be the square root of x raised to the 3rd power. Okay, the square root of x raised to the 3rd power. So we're going to do this. We're going to first get rid of the 3. So we're cubing something. How do we get rid of a cube? By taking its cube roots. Okay, if we have a power, you get rid of a power by rooting. So if it's the 3rd power, we're trying to find the 3rd root. So we have to take the 3rd root of the left and the 3rd root. So that gets rid of the 3. So we just have the square root of x on the left side. And what number multiplies by itself 3 times to give you 8? And that number is 2. 2 times 2 times 2. Right, that's 2 cubed. So the cube root of 8 is the number 2. Okay, so now that we've gotten rid of that, we can now square both sides. To get rid of our square root, we're going to square it. And what is the square of 2? 4. 4 is your answer. Okay, and since it's only one answer, we're going to make sure that it's true. So 4 to the 3/2 power, that sure enough is 8. That's what my calculator says. Okay, so these are kind of strange, I agree, but let's work with them for a minute. Well, this looks very similar to our first problem here, number 7, doesn't it? Something raised to the 3/2 power. Okay, so one thing we can do, of course, is raise it to the reciprocal. So if it's a 3/2 power, we can raise it to the 2/3 power, right? We're reciprocating. So we're flipping those so that they both cancel out. Okay, they both cancel out. So we're just left with an x plus 5. But now we have to deal with this. Okay, so remember the top number is your power, and the bottom number is your root. So we are looking for the third root of 8, and then we're going to square that number. The third root of 8 squared. Or we can look for the third root of 8 squared and square the 8 first. Okay, these ones are interchangeable. But hopefully you know from a second ago, that rhymed, that the third root of 8 is the number 2. Right, because 2 times itself 3 times equals 8, and then 2 squared is 4. Okay, so then when we subtract 5 from both sides, x equals -1. And when we plug this back in here, that's exactly what we get. 4 to the 3/2 power does in fact equal 8. Right, that's what we had over here. X equals 4. That's basically the same problem. Okay, number 9. We have a little bit extra here with number 9 that we have to do before we can get rid of our radical stuff. Okay, so first we're going to add 12. All of our easy elementary problems first. 6x to the 5/2 equals 12. And then we're going to divide both sides by 6. Okay, so we do all of the easy math. I say easy, I mean the elementary things, the adding, the subtracting, the multiplying, the dividing, so we can get to here. Okay, so we're going to get rid of 5/2 by raising it to the reciprocal, which is 2/5, right? The 2/5 power. So if it's a 5 over 2, we raise it to the 2 over 5. So we're going to do that to both sides, raising it to the 2 over 5. Okay, so this is your power. We are squaring the number, and then we are taking the 5th root of that number. Okay, so there's a couple ways we can write this. We can write it as the 5th root of 2 squared. Okay, we can put the 2 underneath the radical, or you could put the 2 outside of the radical, which really won't help us, right? There's not much you can do there. We can simplify this, right? What is 2 squared? 2 squared is 4. Okay, so this might be the simplest way for us to write our solution, is the 5th root of 4. Okay, these rational fractions, right, these radicals that are in fraction mode are kind of something you don't deal with almost ever. So let's see, what else is there over here? Not a whole lot. Okay, a whole lot. So here we're going to do the same thing, right? We're going to raise it to the reciprocal power. So 3/2. 3/2. Okay, and that cancels out your fractions and leaves us with an x minus 4. So we have to deal with 16 to the 3/2 power. So remember, this is the power, and the bottom one is the root. So I think it's easier, right, since it's the second root, that's the square root, the square root of 16 raised to the 3rd power. Okay, let's see if we can do that first. So the square root of 16, what is the square root of 16? Hopefully you know that's 4. And then 4 cubed is 4 times 4 times 4, which is 64. So 4 times 4 is 16. 16 times 4 is 64. So remember, this means 4 times 4 times 4. So x minus 4 equals 64, so let's add 4 to both sides. That way we get x equals 68. Okay, so if we started with 68 and we subtract 4, that gets us to 64. The square root of 64 is, the cube root of 64 is 4, and 4 squared is 16. That one matches up just fine. Okay, so when we have a fractional power, you want to raise it to the reciprocal. And always the top of your fraction is your power, and the bottom of your fraction is your root. Okay, so you can do whichever one you want to do first. You can square something or you can square root it. Whichever one makes most sense to your brain, that's the one you do first. Okay, so there's a little lesson about solving radical and rational equations.